Hello everyone, this is Dr. MiteshGala. Welcome to Rough Book, a learning companion.
Hi, we're getting into tangents and intersecting chords, exercise 18C, part 3. Very long exercise, so I've broken it into parts so that it's easily able to understand. So we're getting into the third part. After this, there is one more part to finish this topic. So there were seven properties right in the beginning that I explained it to you all. Just doing a quick recap. First one, perpendicular tangent drawn at any point on the circle is perpendicular to the radius through that point. Second one, tangents drawn from exterior point to the same circle are congruent, so both the tangents are equal. Third one, tangent secant theorem. So if this is 60 degrees, automatically this will be 30 degrees. And the fourth one, most important, the term angles in alternate segments. This angle is equal to this because both are half of this arc, that is mountain and the valley. The other three properties, that is chords intersecting inside the circle, chords intersecting outside the circle, and tangent secant property. These three I taught you and we've done all the sums of that, but as per the syllabus for this year, it's not there in the portion. But yes, I am going to do all the sums. I want you to know everything nicely. Obviously this year it's not in the portion, so nothing to worry. This year, that means in the year 2020-21, when you are going to attempt the paper, that time these three properties are not a part of your syllabus. Okay, after that, yes, it will be, so you need to study them. So let's go ahead. Sum number 26, one of my favorite. They say AB is a diameter for this semicircle, AM is a diameter for the small semicircle, and one more small semicircle, MP is the diameter, whereas this is a circle with radius R. So let's name these points as point P, Q and R. Alright, I am dropping a line this way and extending this further to meet the two centers of these two circles. Now your target is to prove that AB is 6 times of this small r. Small r is the radius of this small circle. Alright. So how are you going to go about it? Let's call this as S instead of r so that we don't get confused with r at all. Okay. Now for this semicircle, this is a tangent. Therefore this angle is going to be 90 degrees. So triangle PMS is a right angle triangle, and I can apply Pythagoras in this. But to apply Pythagoras, I should start with something, I mean to say some variable should be denoted. So we will say let PM is equal to AP is equal to QM is equal to BQ is equal to capital R. That is this, we are calling it as the radius. Since both of the semicircles are equal, therefore the radii also are equal, and we are calling it as R. So this part is R, is what we already understood. Therefore AM is equal to BM is equal to 2R is equal to MN. That's the main key. See, MN is also the radii of this semicircle. So MN, AM and BM, all of them are 2 times the radius because double of this. And therefore AB, at the moment, we can call it as 4R. See, 1R, 2, 3 and 4R. So this is all going to be helpful to us very soon. Now we'll try and get the 3 sides in terms of R. So therefore, the first one PM is already R, so no problem. Second one, this is also R radius, so PS can be called as R plus R. And MS, this part. Now full MN is R and this NS is small r, the radius. So therefore you get it as R minus R. See, 1 minute, MN is 2R, my bad. So this is going to be 2R minus R, very important. Now let's jump into the triangle PMS and we shall say angle M is 90 degree. Tangent drawn at any point on the circle is perpendicular to the radius through that point. Please write the entire statement. So therefore PM square plus MS square is equal to PS square. Pythagoras theorem. So PM How much is PM? PM is R. So R square. MS, we got that as 2R minus R the whole square. And PS is R plus R. The only confusion where people have is why MS is 2R minus R, because MN is 2R. See, this full thing is 2R. This is radius. This also is a radius. So both are R. So from this 2R we are subtracting R. Therefore 2R minus R. Now open this and automatically you will reach somewhere close to this if you use your common sense. So try it and I am sure most of you all will be able to tackle it. Let's see. So R square, A square plus B square minus 2AB. So that should be 4RR. Likewise A square, B square, 2AB. So this R square and R square gets cancelled. This R square also gets cancelled. This 2 I bring it on the, this 4 I shall bring it on the other side. So 4R square, 4 into, this will be plus 4 plus 2. So 6RR. Now most important thing, 4R square upon capital R, 6R. This R I have sent down. Why? Because I don't need capital R. So I can cancel 1R and I will get 4R is equal to 6R. Are you close? 4R is equal to AB. So you can directly say therefore AB is equal to 6R. And here we can say from 1 and let's call this as 1 so that we've substituted that. That's exactly what you wanted, yeah? Isn't it an interesting question? Yeah, I hope you enjoyed this question. Please go through it twice or thrice. Only then you will be able to get a good hand on it. Let's go to the next one, sum number 28. 28 is not difficult but interesting. They say that AT and BT are tangents to these two circles. P and Q are points which intersect these two circles at. Your target is to prove that AQBT lie on a circle. Basically AQBT is a cyclic quadrilateral. Now to prove any quadrilateral as a cyclic quadrilateral, 3 methods if you remember. 1. Prove opposite angles supplementary. 2. Prove exterior angle equals to interior opposite. And 3. Prove any two angles in the same arc congruent. Now in this case, it's very much evident you will have opposite angles, supplementary. For that we first connect PQ. So you say join PQ. Now be a little smart and see how do we work about with this. So I would say angle TAB. Come on, can you tell me it is equal to which angle? Yeah, did you manage to get? TAB is equal to TQP. Can you tell me why? Angles in alternate segments. See, this is your valley and this is your mountain. So mountain and the valley, correct? So I call this as, let's say, X. Likewise, can I call these two Y and Y? Again, angles in alternate segments. X plus Y plus this angle 180. So X plus Y plus this angle 180. So therefore opposite angles are supplementary. Did I make it simple? Yeah, was it a logical one? So how are you going to write? Step 1. Angle TAB equals to AQP. Angles in alternate segments. Second, TBA equals to BQP. Angles in alternate segments. Third, in triangle TAB, this plus this is equal to 180. Step 4. Step 5, substitute these two. So this plus this 180. And step 6, you will get opposite angle supplementary. Step 7, say therefore it is cyclic quadrilateral. Step 8, therefore say it lies on a circle. So let's see if you can write it on your own without my help. Pause the video. Try it. Even if you don't get, don't worry, but try. So first one, angle TAB is equal to angle AQP. Second one, TBA is equal to BQP. Reason for both, angles in alternate segments. And therefore, now let's jump into the triangle TAB and we shall say angle TAB plus TBA plus ATB is equal to 180, and we shall change the names. So for TAB I will write AQP, for TBA I will write BQP plus ATB. Finally I shall add these two angles. So AQP plus BQP will give me AQB plus 8TB equals to 180. So we got opposite angle supplementary. 7th, therefore quadrilateral AQBT is a cyclic quadrilateral. Reason, since opposite angles are supplementary. And then you can say last statement, statement number 8, therefore A, Q, B and T lie on a circle. That's your final part. Got it, everyone? Interesting, isn't it? So your trump statement or trump property, angles in alternate segments, very important. Let's go to the next one, sum number 31. 31 is simple. I am 100% sure you will manage. This is 12, 16, find TP. So obviously tangent secant property, not in this year, it's in the board, that is 2020-21, but next year onwards it's there. So I want you to get this, please. Come on. So I will say number 1, TP square is equal to TB into TA. Reason will be tangent secant property. Therefore, TP is unknown, TB is 4 and TA is 16. So TP square 64, and therefore we can straight away say TP is equal to 8 centimeters. I'm sure this was very simple and most of you all could tackle it on your own. Brilliant. Let's go to the next one, 32. Now sums are all simple. If you use your brains, 100% you will get. BQ is 27, BC is 38 and DC is 25. These three angles 90 already given to you. Your target is to find the radius of this circle. Can you do it? It's really simple. Just look at the question carefully, not at me. Look at the question carefully and 100% you will get. BQ is equal to, come on, I have given you the first clue. BQ equals to BR equals to 27. Why? Tangents drawn from exterior point to the same circle are congruent. So please write the entire statement. Now if BR is 27, therefore how much will be RC? So 38 minus 27, 11. Now if CR is 11, come on, take it forward. I have given you the clue now. So CR is equal to CS is equal to 11. Again the same reason, tangents drawn from an exterior point to the same circle are congruent. Now if this is 11, I can easily find DS. So DS will be 25 minus 11, that is 14. So if this is 14, this also will be 14. Why? Because this is a square. So you have to prove that it's a square first. So let's do that. So we will say in quadrilateral, DSOP, angle S equals D equals P equals 90. Also OP equals to OS, radii of same circle. So since all angles are 90, adjacent sides are equal, therefore DSOP is a square. And now since it's a square, therefore I can say DS is equal to OP is equal to radius is equal to 14 centimeter. So we managed to get the radius of this circle. Nice, isn't it? It looked difficult, but when you look at it carefully, the start only gives you the entire question. 27, 27, so 11, 11, 11, so 14, 14, so 14. But you have to present it really well. Let's go to the next one, sum number 33. 33 is not difficult, and in fact, let me tell you, if you go to your first exercise, you will find the same sum, I think sum number 22 if I have not mistaken. It's exactly same sum with different alphabets. Same thing has been asked, nothing new. So just showing it to you, 70 and 50 is given. First target BAY, come on, since it's the same question and if you've practiced first exercise really well, you should get this sum. You should not rely on me at all, not even for the clue. So come on, try it. So first thing, this is the diameter also given. So this will be 90. Get this one, subtract and get this. How to get this one? Angle sum property. Simple. So come on, at least get BAY on your own and then come back. So step 1, I will say in triangle AXB. Yeah. Angle XAB is equal to 180 minus 50 minus 70. So therefore I can say AXB equals to 60. Now we'll call this one as 90. So we will say angle XAY is equal to 90. Why is it 90? Tell me the reason. I hope you've learned all the reasons. I have put all the properties in the description. Please take it down nicely. In case if you still not learn, pause now, learn it and then come back. So angle formed in a semicircle is a right angle. Complete the statement. And therefore straight away we can say BAY is 90 minus 60, that is 30. So we managed to get our first answer, BAY. So 30. Now they want APY. So if you remember, we connected this, got this Y, so that this becomes equal to this angles in alternate segments. And then for this triangle, this is the exterior angle equals to sum of remote interior, and you shall get this as 10. Exactly same sum. So let me go a little slow. First let's get this angle. How? So this also is going to be 90, 70, so 20. And then this is equal to this mountain and the valley, so angles in alternate segments 20. And then we look at only this triangle APY. So this is the exterior angle equals to sum of remote interior, that is remote interior angle theorem, and get this 10. So come on, pause right now and write the entire sum on your own. Step 6. So firstly I will say angle XBY is also 90. Angle formed in a semicircle is a right angle, and therefore angle ABY will be equal to 90 minus 70, that is 20. Therefore angle ABY, this one which is 20, will be equal to this one AYP. If you still not followed, look, this is ABY and this is AYP. Mountain valley angles in alternate segments is equal to 20. So angles in alternate segments. So we managed to get this 20. Now for this last one, so I will say angle BAY is equal to angle APY plus angle AYP, remote interior angle theorem. And therefore step 10, BAY is 30 is equal to APY 20 plus AYP. Oh, APY is not 20, AYP is 20 and plus APY. So finally I can say therefore angle APY 10 degrees. That's what our last part is. Yeah, I hope many of you all were able to do this on your own. Were you? Please write it in the comment section and tell me, so I will be really proud of you. Thank you so much. Let's go to the next one, 34. 34 is not difficult either. This is given to you as 36 and 42. First target BAP. So BAP right over here. Damn simple. Come on. 36. Super. Who said it? Angles in alternate segments. Mountain and the valley. Can we look at it carefully? Mountain and the valley. So this is equal to this 36. Next is ABD. That is over here. So exterior angle, sum of remote interior. So 42 plus 36, 78 exterior angle. So at least let's get these two, then we'll talk about the rest of the two. So first one, angle BCA is equal to angle BAP. The reason will be angles in alternate segments, and therefore BAP is equal to 36. So we got our first angle. Now for the next one, angle ABD is equal to BAP plus BPA, remote interior angle theorem, and therefore angle ABD will be BAP 42 plus 36, 78. So we managed to get the second part as well. Yeah. So first and second sorted. Now QAD, which is here. So first let me write this 36, 78. Come on, it's simple now. Yes, again mountain and the valley. So 78. Getting it? Angles in alternate. I told you it's a Trump property. So angle ABD is equal to angle DAQ or QAD is equal to 78. Angles in alternate segments. So we managed to get our second angle also straight away. Third rather, not second. And lastly BCD. So BCD is this full angle. Come on, one property and you should get this. Okay, let me tell you it's 78. Why? Not 78, sorry, not 78. No, not 78. It's not one property, we'll have to think. Because I thought this is exterior angle to a cyclic quadrilateral, but this is not the exterior. Because the exterior would go down. So if you say this is 78, 78, that's wrong. Huh? Because BA extended, so DA to that extended is the exterior angle and not this one. So how will I get this one now? Any clue? So I think this can be said as 78. Yeah. Angles inscribed in the same arc, and then we can add the two. That's the easiest method. So let's say angle ABD equals to ACD equals to 78. Angles inscribed in same arc are congruent. No short forms allowed in the exam. So finally now we'll get into the last part, that is BCD. So BCD is this plus this, that is 36 plus 78, 114. So final answer therefore BCD 114 degrees. Got it? Simple. Did we really enjoy this one? How many of you all managed to get this on your own? If you're getting it, nothing like it. Brilliant. Let's go to the next one. 35. This is a 2006 board question. Let's see if you are capable for the board question now. This is given to you 34. CBA. I don't know whether this is the diameter. Let me just check. 35. Yes, AB is a diameter. So damn simple now. Take this 90, get this angle some property, and then CQB, which is here. So we'll talk about that later. First let's get this one. So step 1. I will say angle ACB 90. Reason will be angle formed in a semicircle is a right angle. So you got this 90 degree. Now for this one, so in triangle ACB, we shall say angle CBA is equal to 180 minus 90 minus 34. So finally therefore CBA 124, so subtract 124, 56 I guess. Yeah. So we got the first one, that is CBA 54. Now for the next one, CQB. How shall we get this angle? Is this simple? Very simple. This is equal to this mountain and the valley. So this will be 34, and then exterior equals to sum of remote interior. So you will get this as 20. Yeah. So come on, write it. So angle CAB is equal to angle BCQ equals to 34 degrees. Angles in alternate segments. And then finally, once you got this 34, let's get this angle. So we will say angle CBA is equal to BCQ plus angle CQB. Remote interior angle theorem. So therefore, CBA 54, BCQ 34 plus CQB. So finally I will say therefore CQB 20 degrees. So we managed to get both the angles. Anyone out over there getting all this on his own or her own? Please write it in the comment section and let me know that. Last question for this video and then we'll break. So the rest of the questions we'll do in the next video and finish this chapter rather, not only the exercise. So you've been given this 55 lines are parallel towards the center. First target BOD. Damn simple. Go reverse. We want this angle at the center double the angle on circumference to get this alternate angles. So 55, 110. Simple. Next one, BPD. Don't say opposite angles of cyclic quadrilateral because this is not cyclic. Did anyone say that? Seriously? Okay. How will you get this one then? So you will say this is 90 because tangent. This is also 90. So you got in this quadrilateral total as 360. Subtract these three angles and get this. So come on, pause, write on your own full question and then come back. So first one, ABC is equal to BCD is equal to 55. Alternate angles. So we got this 55. Now we are getting the central angle. So we will say BOD double of BCD. Reason will be angle at the center is double the angle on circumference. Complete statement please write. So therefore angle BOD will be double of 55, that's 110. So we managed to get this angle as 110, the first part which they asked us. Now for the last part, BPD. First we'll have to say these two angles are 90. So we'll say angle OBP is equal to ODP is equal to 90. Tangent, come on, complete it. Drawn at any point on the circle is perpendicular to the radius through that point. Please write it. And finally, in quadrilateral OBPD, we will say angle BPD is 360 minus 90, 90, 110. So therefore I shall get BPD as 70. And that's your final part. Did you tackle this? Yeah. If you are getting all these sums, brilliant. If you are not getting, that means you are not doing an honest job. So please look at the properties first in the description out over there. Download, learn it, put on your softboard and then start with the question. For your homework, I want you to do 26, 28, 30, 34, 36. I'm repeating few questions so that you get a good hand on them. So please don't cheat. Alright. Until the next video, take care, stay safe, pray for everyone and be honest. Bye.
Hope you had a lovely mathematics experience with the Rough Book, our learning companion.